What's happening, guys? Mr. Allen here. We want to find the area of a quadrilateral that is inscribed in a circle if it has side lengths 8, 9, 12, and 13. So it's inscribed in a circle. Let's draw that up. All right, so there we go. We have a circle, and inside that we have the quadrilateral. It's inscribed, meaning all four vertices lie on the circle. We can also call this a cyclic quadrilateral. Okay, that means it is inscribed in a circle, or can be inscribed in a circle. All right. So how am I going to figure out the area of this quadrilateral? Now, initially you were thinking, hey man, maybe I can like divide this thing up into a couple triangles. That's usually a pretty good move, right? But I don't know where that line's going to go. I don't know if it's going to go through the center or not. And I don't even have any like right angles or any other angle measures or anything that I can deal with here. We're kind of at a dead end here unless a math superhero arrives. And boom, there we go. Not Hero, but his buddy, Brahmagupta. So one day Hero was hanging around and he's like, man, I got to figure out this quadrilateral, but I can't figure it out. I needed some other kind of formula. And then Brahmagupta's like, yo, brah, I got you. Okay. And he took his same formula looking thing and he just expanded upon it. I think. I don't know. I think that's the history. I think that's correct. You can just go ahead and Google search that and it's probably going to be right. Anyways, let's get after it. Same kind of idea here. We got to find our semiperimeter and then we can plug it into that wonderful looking formula. So first thing, let's get that semiperimeter. Shall we? I think we shall. Alrighty. So my semiperimeter is all my sides added up, 8 plus 9 plus 12 plus 13, all divided by 2. That's going to be 42. Divided by 2, so my semiperimeter is 21. Now, we can go ahead and plug this into Brahmagupta's formula. And really, both of these things are part of Brahmagupta's formula. It's really like a two-part formula, just like Hero's formula. So, our area is going to be the square root of, and then we're going to have 21 minus one of the sides, and then 21 minus the other, 21 minus the next one, and 21 minus the last one. There we go. Okay. So now I've got 13 times 12 times 9 times 8. And if you're wondering, like, hey, can I just multiply all my sides together? Coincidence on this one, guys. Coincidence, but I'm glad you're observant, right? You're like, hey, man, is there an easier way? Sorry, not quite the case. All right, let's go. So I got to multiply all those guys together. That's a really big number, right? 13 times 12 times 9 times 8. That's going to give me 11,232. All right, area 11,232. And you're going to be expected to break that down. What? Are you insane, bro? Hold on. Let's see if we can cheat the system here. Are you ready? I'm going to give ourselves a little bit of room. I'm going to give us a little bit of room. So if we look back at this step right here, we already know how this thing can be broken down. Can we be strategic with that? Well, with this 12 and this 8, I can get some 4s out. So that means I can divide by 16. But with this 9, right, that's a 3 and a 3. So I can also divide by a 9, 16 and 9. So I can do 16 times 9. That's going to give me 144. Okay. So I could take that 11,232 and divide it by 144. That's going to give me 78. And the only way that 78 is going to be broken down is by like a 13, a 3, and a 2, right? You can go ahead and try that, but you're going to hit a dead end with the factor tree on that 78, right? I'll even do it. We'll divide that thing by 2, all right? And I'm going to get 39. So 2, 39. Then I'm going to get 3 and 13, right? No pairs there. But the square root of 144 is 12. So I'm going to have 12 square root 78. And I don't know if we had any units on this one. It does not. So units squared. That will be my final answer. Breaking that one down is a bit of a challenge there, right? Looking into those numbers and kind of cheating the system, kind of challenging. You could divide by 2 over and over and over and over again, and you get a lot of 2s, right? But hey, either way, 2s and 3s come out. You can simplify it. I just did a little bit of a shortcut method. But in any event, that's Brahmagupta's formula. Again, very special case scenario to be able to find some areas, but hey, pretty dope formula no less. You guys have a good one.